dear colleagues and my dear students. It gives me an immense pleasure to welcome today's eminent speaker, Dr. Damayanti Bagra. She is Associate Professor in Civil Engineering Department in SNPITC RC College, Umrik. Madam has completed a BTech from Lagdej Engineering College, Morbi, from where I have completed pursued my BTech degree. And Madam has pursued MTech and PhD in structural engineering from SVNIT Surat. Madam has published more than 45 papers in various national and international journals and conferences. And Madam is lifetime member of more than 10 professional organizations like AAC, AIC, IST, IAM, ISSC, ICSE, and much more. And Madam has delivered so many lectures, not only in national but international level as well. And she is a recipient of Best Young Researcher National Award and Young Scientist Award for 2 consecutive years, 2016 and 17, and Best Paper Award in one of the national conferences. And Madam has faced financial grant of rupees 75,000 and so many feathers in her cap in so young age. If I describe all, then whole hour will be consumed. So without wasting further time, I will invite Madam to deliver his talk. Madam, session is yours.
Um, Thank you so much, Dr. Jayesh sir, for such a nice introduction of mine. Sir, my PPT is visible and am I audible?
Yes, Madam, perfectly.
Okay, fine. So, first of all, good morning to respected director, trust member, department head, all the faculty members of Parul Institute of Engineering and Technology, because you inviting me in this such knowledge sharing session for the students. So, I welcome all my dear students who are present over here and audience who is listening me live. Again, I am also thankful to my management, my institute, SN Patel Institute of Technology and Research Center, Umrah, who gave me that time to participate in knowledge sharing activity through this expert talk. So, without wasting much time, as time is like money, and we have to invest that money in a proper manner. So, today I will discuss the topic recent advancement in the field of concrete focusing on smart material, right? So first of all, thing should be that what is smart material, right? So once smart will come in picture, so there are things that ordinary things should be avoided. We are focusing on in the field of concrete, right? So whenever concrete word come in picture, so water will come in a highlight, then cement, sand, aggregate, different type of material come in picture. Home will come in picture, then roads, building, such type of structure automatically come in pictures, right? But here we have to focus on smart materials. So we know that the properties and everything about the concrete, right? That concrete is a simply made from water, cement, and aggregate as per the ancient time, as per the past era. Means whatever knowledge we have regarding the concrete. So there is a simple terminology that water will be there, cement will be there, aggregates will be there, and combination of all these material combined we will call as concrete, and that will be used for like building, home preparation, and everything. Such type of fundamental thing will come. But as we are the civil engineering fraternity, and yes, we are studying in a very reputed institutions, and we are having a lots of resources. So we are having knowledge that concrete is not simply with that material, but there are extraordinary materials, admixtures, super plasticizer to enhance the characteristics of concrete. So which type of characteristic? Means mainly concrete is known for the compressive strength, and we know that tensile strength of concrete is weak. But whenever concrete is concerned, we are focusing to prepare building, residential building, industrial building, road, bridge, tunnel, and there are lots of advanced structure which we can make for concrete. So at that place, not only compressive strength will play a very vital role, but the tensile strength, impact strength, then there are lots of flexural strength, there are lots of strengths that will come in picture, that we have to check all the strengths for that particular structure, so that ordinary material will not play that much important role. And at the day by day development, we have to investigate the smart material. So smart material will be not like that. If we add something and our concrete will make a little bit advanced and this is the smart material, such things will be not there. If we added any material, any other ingredient in concrete, and if our concrete characteristic is improved in all the aspects, fine, we are adding something, so all the aspects should be improved. If we are getting any disadvantage from that material, means one property is increasing and one property is down, so this is not called a smart material, right? Because some people and some researchers having some confusion what they are doing, they are investing some material and because of that any property is increasing, so they are thinking this is the smart material which is enhance the properties of concrete. But actually there are lots of parameters that which we have to focus while making the concrete. If any parameter going down, so this is the disadvantage, and that's why we can't consider such type of material as a smart material, right? So again, that whenever concrete will be there, so what we called smart material in concrete, so water, cement, aggregate, and admixtures, super plasticizers, various type of supplementary cementitious materials. Because there is a lots of research has been done as well. I'm telling with that much confidence? Because I completed my PhD on especially on this topic. Okay, and I did lots of research on that by referring so many literature survey, by visiting many industries. So with much confidence, I can say that there are different type of supplementary cementitious materials are available in a market, are available with the various industries as their byproduct, as a raw material, as called waste material. These materials enhancing the properties of concrete in different fields, and it is also advantageous in a cost cutting matter, and there are lots of positive factor of that materials, and that's why these materials are called as a smart material in the field of concrete, because they are what we can say, they are just increasing the strength, increasing or like enhancing the various properties of concrete. So simply we can say that water, cement, aggregate, admixtures, then super plasticizer, supplementary cementitious materials. Whenever that admixture, super plasticizer, and supplementary cementitious material will come in picture while making the concrete, so we can say that yes, this is the smart material whenever we are talking about the concrete. So here you can see in the picture. Now water is there, cement is there, aggregate is there. This is the general trend. But one advanced step was the admixture or super plasticizer, and after that one advanced stage is the supplementary cementitious material. From the, if you can see my slide, so last one is like SCM. So there are different type of supplementary cementitious materials are there in a various color. But why this is the supplementary cementitious material? Because we are using in a place of cement. And my dear audience, here I want to be very clear that whenever we are making a 1 ton of cement production, concrete production, so at that time, at same time, 1 ton of CO2 emission will be generated in environment, and this is a very bad for our civil engineering field, right? Because no doubt we are doing development and everything, but simultaneously because of our that development and our concrete manufacturing, cement manufacturing process, if CO2 is generating, so this is a matter of problem. We have to look after that, how we can overcome that problem, right? So we investigated that supplementary cementitious material, which are the byproducts, or we can say these are the industrial waste we collected from the different industries. So we can say that we are helping various industries for the waste management problem by collecting their waste in our construction field, right? Then whenever we are reducing the use of cement in concrete manufacturing, so directly we can see that we are reducing the CO2 emission in environment, because if less use of cement means less emission of CO2 in environment. Okay, so these are the different type of supplementary cementitious materials, which we called as the smart materials in our concrete field. So today we will discuss all the advanced smart material which are come under supplementary cementitious material, right? So we can say that whatever general term I want to discuss, that we already just discuss in a formal talk. So I will not read the PPT. But yes, it would be incorrect infer from the previous historical account that the supplementary cementitious material were introduced into concrete solely by the push of their availability, right? These material also bestow various desirable properties on concrete, sometimes in a fresh state, but more often in hardened state. Whenever concrete will be there, so mainly we are focusing on hardened properties, but not only in hardened properties, but whenever concrete will be in a fresh state, fine, in a workable condition. So at that time also its properties will be advantageous, like it's a flow, it is a workable or not, it is a pumpable or not, right? So these properties are also enhanced, and after the hardening of concrete means after 28 days, or we can say that after concrete exactly harden after some time, so what will be its strength in a different era, not only in a compressive aspect but a tensile, flexural, impact, okay, then abrasion value, toughness, so many factors will be that will become under hardened state. So that supplementary cementitious material also that enhance that hardened properties also, and fresh properties also. It is therefore inappropriate to consider them as was sometime done in the past as cement replacement material or as extenders. So we can't say that it is like extenders only. There are the exactly a smart material considering the supplementary cementitious material in a concrete production. So now, if many of you are aware about that material, so detail we will discuss on that. So before discussing that material, we will go with the list that which supplementary cementitious material exactly right now in the field we are using, and which are having a really good properties which enhance the concrete, and what smart role they are playing in a concrete production work, right? So there is a list like fly ash, ground granulated, blast furnace slag, rice hushed as nanosilica, mint silica fume, the metakaolin, municipal solid waste ash, bagasse ash, and there are lots of other materials also. But as the time is constrained, so we will try to cover most of the material, right? But the list is very vast. There are lots of material, but these are the complete material which practically fit in a practical way we can use in concrete manufacturing, and many people are using that in their research also, and some places they are using in construction work also. But because of the lack of awareness, or because of the lack of knowledge, or maybe some fear, people are not revealing that what they used. Okay, when I completed my PhD and I want to check that that material is suitable or not, I collected waste from one of the local steel industry, and I used that waste in a cement replacement for concrete manufacturing purpose, and that material found very good because what we did like a 10 to 100% replacement at a 10% interval, like 100% cement will be there. So our concrete made from 100% cement, but afterward we collected steel industry waste that converted in a powder form, and that like a 90% cement will be there, so waste will be 10%, 80% cement will be there, so waste will be 20%. So such type of different variation we did, and lots of cube casting and lots of work we have done. But afterward we have to see that this is the like laboratory work, right? We have to do practical and everything in a very good manner, but when we are actually using in a field, so is it visible that structure can sustain or not? So that material we used in Ichhapur for one water tank, and one I can say like 200 to 300-meter road prepared from that material, and that work was done in around 2017, and it is a 2021, but that structure is still in a very good condition, and we are continuously monitoring that is there any defect, any crack, or any bad thing in that structure. But till now after my completion of that work, I applied on field, and till date, it is sustained in a very good manner, and we are expecting that will. Okay. So first of all, we will talk about fly ash. So in a like a right corner, you can see one like powder type of heap is there. This is nothing but this is a fly ash in a powder form. So pozzolanic material, which is we call as a natural pozzolana, was first found at Pozzolani near Nepal and got its name based on this chocolate red volcanic earth. Some waste and byproduct have properties similar to natural pozzolana, such as coal, fly ash, which is most commonly used in the production of concrete, right? Coal fly ash, or generally referred as a fly ash, we are considering as a capital FA, right? It's a byproduct of the combustion of pulverized coal in thermal power plant, and in Gujarat there are lots of thermal power plant. So from that, researcher can get that fly ash and in a powder form they can use in concrete manufacturing. And what will be the advantage that we will discuss. Depending on the type and quality, fly ash consists of a different proportion of oxide, mostly silica, aluminium, than calcium, and can display pozzolanic activity too. This allows it to be a substitution of cement and fine aggregate in concrete. Means in a place of cement, in a place of fine aggregate, we can use that fly ash. Here in a picture, you can clearly see in a truck fly ash is there, right? People is laying on one road, right? And one person in another picture by using fly ash by roller, they are making the road, right? So besides fly ash, coal burning power plants also generate bottom ash, which consists of coarse granular particles collected at the bottom of coal furnace. These particles are very porous, irregular, rough textured, and lighter than the natural aggregate, right? Coal-based ash can be used in a road bases like structural fill, drainage media, masonry asphalt, and there are lots of use of that fly ash in a like a granular form also and in a powder form also. But in a picture, that pictures are taken from a Google simply. So this is only showing that the use of fly ash in a road making activity. Okay, this is also our field of civil engineering. So generally we are talking about the use of fly ash. So by that pie chart, you can understand that if we are talking about any structural fields, any embankment is there. So 46.6% of that fly ash used in that sector. In agriculture field, this is less than 0.1%. If mineral filler will be there, then like around 0.2% use of asphalt will be there. In a mining application, this is a 1% use for blasting grit, roofing granules, there is a 1% use. When we are talking about waste stabilization, solidification, soil modification, snow ice control, then for concrete, various products for aggregate, then there are also some other use also, mainly in a road base, right? So we can say that from that pie chart, we came to know and we can understand that fly ash is using in a different places in a very good manner. So this is a one of the good supplementary cementitious material when we are talking about the concrete. So what is the characteristic of that material? So fly ash is a byproduct material and its physical, mineralogical and chemical properties strongly depend on the type and mineralogical composition of coal, processing condition of the furnace and the collection and storage of the fly ash. These properties vary not only from one powder plant to another, but also within one plant. Means it is not like that if I am talking about fly ash good properties, so that will be similar at all the place. Okay, because at every place that ground level, then it's a geological conditions, it's a soil type, everything is a change. Okay, so if one plant will be there, so if in a one batch, one fly ash having a property, so in a different batch, means in a second batch, same property will be not there. There will be some like a 10% variation will be there. And in our field, 10% variation is allowed when we are talking about any product. Okay. In a view of concrete only. Okay. I'm not talking about any other material, but in a concrete. So we are talking about when physical properties. So scanning electronic microscopy, which way we can say that SEM, right, shows that Fine aggregate is a heterogeneous material containing particles of different dimension and shape. We all are aware about that. Generally, fly ash particles can be rounded, irregular, or angular, but they are mostly spherical. The particle surface is generally smooth, but it varies between different type of fly ash. Shape and quality of fly ash particle surface affect the amount of water needed for the desired workability of fly ash concrete. Moisture of fly ash is an important physical property, mostly because high moisture content in fly ash will cause its hardening, especially if a high calcium amount will be present in fly ash. Okay, so this is the scanning electronic microscopy images of a fly ash. So from that we can see various shape of that fly ash, whatever type and whatever places are there. So as per that we collected fly ash. We are collected means this is the picture taken from the researcher's paper to understand the various shape of fly ash in a ACM images, right? Now we are talking about chemical and mineralogical properties. So we know that major ingredient of most of the fly ash are silica, alumina, calcium, iron oxides. Okay, and besides of them, if we are talking, then magnesium, sodium, titanium, sulfur, potassium are the which can compositions which are present in fly ash. But unburned carbon, generally presented through loss of ignition, is also an important constituent influencing high water and admixture requirement in concrete containing fly ash. Why I am talking again and again about high water and admixtures and water and everything? Because whenever high water will be there, so there is a chances of concrete quality means decrement in a concrete quality. Fine, that will be not that much good quality concrete will be there with the high amount of water. But this material is smart, having a good properties, and if only one disadvantage that it is taking much water. So why should we not go for the admixture or super plasticizer, right? So that any admixture which like we can say that water reducing agents or water reducing admixtures, water reducing plasticizers that we will use whenever we are making fly ash concrete. So that will give very tremendous results. Okay, and that one negative factor that in a fly ash concrete means whenever we are using fly ash in concrete manufacturing and we are going for high water, so how to reduce that solution we have? Okay, so that's why because of that one negative point also we can use that fly ash. Otherwise you will tell that man told if any negativity will be there in any other matter, so how we can consider it a smart material? But yes, it's having a lots of good properties, lots of good advantage of that material. Only one parameter is there, it is taking a high water, but we are having a solution as a super plasticizer or admixture, right? So by using that we can consider as a smart material in concrete production. Okay, so whatever chemical composition I told you, so here is the percentage range. Okay, and it will vary from, this is the given in a range. Why? Because just before I told at every places the property will differ, right? So it will be not like that if in a Surat SiO2 content it is 11.8, so in Baroda same content will be there. Okay, so that's why results are given in a range. Okay, so there are classifications also, so based on the its a color, its a shape, its a size, from where it is available. So class N type, class F type, class C type, that type of classification is done, right? So natural pozzolana such as volcanic ash, then any calcine clay, metakaolin clay, rice husk ash, such type of product will be there, and from that we are collecting ashes, right? So this is a class N type. If fly ash product by burning any bituminous coal or any like pozzolanic properties, so that will be in a class F. And if we are talking that if lignite or any subbituminous coal will be there, we are burning that, and if we are collecting ash, so that will be class C. So based on the availability of material, whatever we are burning and what is the final product, so we for a fly ash concrete, right? So there are also European standard also given classification like ABC. So in that LOI, loss of ignition, Maximum LOI less than 5% will come under class A. Maximum LOI less than 7% come with class B. Under classification C, maximum LOI will be less than 9%, right? And based on fineness, okay, how fine it is, right? So based on fineness, there are two types, type N and type S. So less than 40%, the means it will pass through 45 micron Indian standard sieve. It will pass through that, so this is type N. And if that whatever material we like we are doing the sieving and whatever material retain on 45 micrometer Indian standard sieve, okay, so that will be type S. Okay, this is the chemical properties of fly ash as per the American standard of testing material and the European standard. So these are the classifications given. Okay. So just that this is only for knowledge, but as a batch to batch, as a place to place, that data will be where. Okay, because whenever any standard will be there, whenever any specification is there, any draft is there, any guideline is there, so this is based on some research. Okay, this is the base and guideline for us, but whenever we are doing any work and we are getting data not exactly that, so this is not a matter of worry. Fine, because it is a very clear picture. Like before so many years, any person did such research and they get data. So is it like that? Ki after 100 years, same result we will get. Okay, so what is the research? So what is the advancement? Okay, and what we are finding. So whenever we are using any guideline, any specification, any standard, so we have to consider it as a base. But yes, we have to keep in mind if here value is a 50 and you are getting 100, then there is a matter of problem and matter of thinking and again research why it is a 50 and 100. That much difference we can't tolerate, but yes, in our concrete field we are expecting till 10% variation plus or minus, right? Now fly ash in concrete as per like American standard, as per European standard, as per the available guideline, maximum cement replacement of 33% of cement mass is widely used and supported by extensive research. Okay, so whatever properties we are having, whatever good properties having the concrete, so as per that, exactly 33% of like replacement with cement can be like we can use. CanMed, this is the in 1985, the Advanced Concrete Technology Group of CanMed Canada started a project to develop structural high performance, high volume fly ash concrete. This is called as HVFAC. Within the CanMed project, typical mixture proportion of low, moderate, and for high strength, and for that they fix some grade like 20 megapascal, 30 megapascal, 40 megapascal. So what it contains, the 20 megapascal strength after 28 days of that concrete casting after the curing, right? So minimum for 50% of class F fly ash in a total cement mass. This is like less than 400 kilogram per meter cube CM was used in that project. Lower water content was there, that was 130 kilogram per meter cube. Then Portland cement like contained generally less than 200 kilogram per meter cube. So such type of data used by CanMed Canada to produce a high volume fly ash concrete. Okay. So here we can see that what is the high volume fly ash concrete. So I will not read all the content over here, but from figure itself I will discuss that from first figure you can see water, cement, fine aggregate, coarse aggregate, and some air will be there in concrete. In second figure, you are observing HVFAC, means high volume fly ash concrete. Here you can see cement portion and fine aggregate portion is more, but in second picture you can see cement content is less. Okay, and there is a use of a fly ash and some fine aggregate also reduced over here. Okay, another high volume fly ash concrete, how we can prepare? Water will be that quantity, cement is there, fly ash is there. Okay, fine aggregate fly ash content we will little bit increase, little bit decrease, and fine aggregate we can little bit increase or decrease. And as per fine aggregate we can decrease or increase coarse aggregate. Okay, so we can say by fly ash content in a high volume fly ash means fly ash content will be same for a different categories of concrete manufacturing, but by setting the fine aggregate and coarse aggregate means if we are using a more fine aggregate, then coarse aggregate will be in a very lesser portion. If we are using a very less fine aggregate, then coarse aggregate will be in a very higher proportion. Okay, so as per that, by using a fly ash in a place of concrete, we can make a high volume fly ash concrete. Yes, it is giving a in a fly ash concrete. This is reduces the water demand for given workability. It is a spherical and smooth, so we can say that there is a like durability properties will be also good in a high volume fly ash concrete, right? The low water cement ratio will be there, so we can say that bleeding segregation problem will be avoided because whenever concrete manufacturing is there, and if you visited any site, so that bleeding segregation problem means concrete will be there, and you can see that concrete lump is at some place and water is outer from that concrete lump, then you are seeing that like concrete is not properly well mixed. So such type of problem are on field. Okay, but when we are using such concrete, so we can avoid such type of problem. Okay, here are the mechanical properties. So you can see that if a different water cement ratio will be there, if the same weighted water cement ratio will be there. So what is the change over here? Like high volume flash concrete compressive strength is lower for all mixes for the same water cement ratio. Okay, and that generally decrease with the increasing of fly ash amount. If a high volume fly ash concrete water cement is ratio is lower, right? So compressive strength can be similar or it can be improved also. And this is the fact and universal truth. Whenever we are going for high water cement ratio, then definitely we have to compromise with the strength. And in concrete, we can't compromise with strength. So we have to find alternative solution. Same way, this is dealing with the strength and water cement ratio, whatever discussed in a previous slide. So reasons for laser use of HPFAC. We think that we discussed so much, but why we are not using in a that much amount these high volume fly ash concrete? So yes, means there is a little bit inconsistency of fly ash characteristic. Lower or early age strength means we need early age strength very quickly, then it will not work at that places. And right now, construction and everything is going in a very fast manner, so that will not work out. Then contradiction in the results found in the existing literature regarding physical, mechanical, and durability properties means different researchers having a different results means not that much combination or not that much similarity in the results or not that much variation that we accept that yes, this is the perfect and we can use. So there are lots of contradiction, lots of result variation, so people are getting confused to use that HVFS in a practical field, and that's why this is not in a proper use. If we go like a series taste, okay, taste series one by one, if one person or one team will do one by one taste series on that HVFC, then we can get exact idea that in how much amount, what we have to use and how we have to use. Okay, lack of adequate standard, yes, no any that much perfect guideline, right? Lack of result regarding the full structural element made with the HVFSC. This is the least data available regarding the structural element which prepared from HVFSC. This is also the one reason people are not using in a that much good way this HVFSC. Then poor durability, right? And that poor durability we can't tell because of the fly ash, but because of the lack of knowledge, lack of awareness, lack of the standard availability, lack of the consistent result or taste series in that field. Okay, so we can't blame that material. Then another material is the GGBFS. Most of people know GGBFS. This is the material which we collected from the steel industry during the iron ore process. Okay, whenever we are extracting iron ore, so one like a granular sand type of brownish or whitish type of granular material will come out during the iron ore process, and that material is a ground granulated blast furnace slag. Simply that material is in a powder form. Here I put my own picture when I did my PhD and I collected. So from that image you can see here is a heap of that material GGBFS. This is a look like a sand, brown sand. Okay, this is look like a sand. It is a, you can see here some water is there. So it is a wet material. We have to do sun drying process. Then means sun drying only, oven drying, and that will reduce its characteristic. So that's why we go for the sun drying. And after sun drying, we go for the powder. Here in another picture, you can see one plant is there when we grinded that material in a powder form. And then powder form we can use in concrete. So this is the physical properties of GGBFS. If any material will be there, then we have to first look after its a physical and chemical property. Why? Because we are using in concrete as a supplementary cementitious material. Material we can use in a place of cement, in a place of aggregate. But here we are talking about in a place of cement, because if I will discuss each and every material by focusing on fine aggregate replacement, by focusing on coarse aggregate replacement, by focusing on that cement replacement, if in a place of water, what another alternative we can use. So I think I need 1 week to explain each and everything. Okay, but I am having a like specific time, so I'm focusing on the cement replacement type of material mostly. But if anyone interested, so they will get my contact from the organizer and they can contact me. I will share every detail, share my knowledge with you guys. So whenever any material we are talking, so we have to focus on physical and chemical properties at first, because we are doing this for cement replacement. So these properties similar to cement or not, or it is matching, or is it nearby to that cement? Okay. So first of all, we have to focus on physical and chemical. That's why in each and every slide, I will share the physical and chemical analysis properties. So you can think that yes, these properties are similar type of cement, so we can use with the confidence as a cement replacement, right? So these are the chemical properties like silica, alumina, calcium, magnesium. As a civil engineering fraternity people, we know that these type of materials should be, means these type of constitutions, or we can say compositions, should be there in a cement. So definitely any supplementary cementitious material, or means we can say that any material which is similar like a cement, so such type of elements should be there. Okay. So blast furnace slag is a glassy material when cooled rapidly by water, right? And as per the figures I shown you in a previous slide, so this is a granular material and we have to grind, and then we can use as a supplementary cementitious material in a place of cement. Okay. So when we are talking about the fresh properties of mortar, concrete containing that GGBFS, then the blast furnace slag increase the workability. So if workability is good, in any place we can use that concrete mortar. Compaction factor test results show that ratio of water cement material decrease in order to maintain same workability of concrete mix with 0% GGBFS. Okay. So whenever we are increasing or when we are using GGBFS, so our concrete workability will be improved, but at certain limit. If I will discuss about my case, okay, I perform the test series. So by my test series, why I am saying I perform test series and why I am telling with confidence? Why? Because from 100% cement to 10% variation, 20% variation, 30%, 40%, 50%, 60%, 70%, 80%, 90%. Means all variation I tried. For all variation I checked all the strength. So yes, from my research, from my experience, from data available to me, whatever test series continuously I done, based on that, I can share my experience that 50% replacement of GGBFS is very good, right? And if I will not read each and every line, and if I will summarize the GGBFS as per my knowledge, experience, and work, then yes, in a 50% replacement of that GGBFS with the cement for concrete manufacturing, we can make a very good grade of concrete, like high performance concrete we can make, high strength concrete we make, having a good tensile properties, having a good flexural properties, having a good all the mixed properties parameters will be good. We can use the GGBFS in a very good manner, because this is my personal experience, because I did a lot of work in that. Another materials, on that material I am sharing the experience of other researchers and other literatures work, right? So after 28 days, after 3 days, after 7 days, after 50 days, after 60 days, after 90 days, 120 days, or we can say that after 120 days even, means till 180 days. After 6 months also, we got very good result. Okay. And yes, my dear friends, that was my PhD, so that was not possible for me to continuously taste for 1 year, 2 year, 3 year, 4 year. Okay, because then I have also write my thesis, and I also have to complete my PhD. So yes, till 6 month, 1 year data, we tested the result and it found good. And still we are having a lots of specimen from that, and still we are having. So yes, we can taste it. And I just before told you that one small 300 to 300 to 200 meter, one small road we prepared, and one water tank we prepared, and it is still existing in a good manner. So we can say that yes, whatever work we done, that was actually good and in a true manner. So this is the ACM images from my work. Here you can see the microstructure of the concrete, which we made with the 50% replacement of cement with a GGBFS. This image is from my own research work. So here you can see the aggregate matrix, interfacial transition zone, and after the breaking, concrete having some internal crack. So that crack is very minor, 6.73 micrometer, 6.41 micrometer. Okay, here you can also see the aggregate microcrack in interfacial transition zone. That was not measurable, so I didn't mention that measurement over here, right? But here in another image, you can see the microcrack in interfacial transition zone, and that was 8.13 micrometer. Okay. So from that ACM images, we can see there is a good bond. Okay, good bond between the matrix. Matrix means your cement, aggregate, water, right? So good bond between the matrix when we are using a 50% GGBFS as a cement replacement. And as I told that its hardening properties are good. Here you can see the result of porosity with the GGBFS replacement. And as I discussed, whenever we are preparing concrete from GGBFS, so definitely its properties are good. When we are talking about the rice husk ash, so rice husk ash are hardened protective covering of a rice grains cover that we are burning, and after that whatever ash is there, this is the rice husk ash. Okay, so the characteristic of ash are depend on composition of rice husk and the burning temperature and the burning time. Here you can see the ACM image of that. Here you can see that no doubt it's a microstructure is a good, right? But how it will affect on concrete property, for that we have to see over here. This is the schematic diagram. By discussing the line by line, I will prefer to discuss that figure. Here 0 to 3 hours, you can see that calcium is there, silica is there, cement is there. This is the like hydration mechanism after 3 to 8 hours. This is the mechanism of after 8 to 40 hours. And after 40 hours, you can see the exact CSH gel formation in a rice husk ash concrete, right? Rice husk ash is a blended cement, is known to contribute to concrete strength from as early 1 to 3 days after maturing. In addition to its contribution to strength, even at relatively small replacement dosage of 10% by weight of cement. Okay, so in a rice husk ash, we can say if we are focusing on good result, okay, material is the smart and it is the good, but replacement we have to decide. Is this material good at a 10% replacement? So definitely this is the smart material, but if you are using it beyond the limit and you are decreasing the concrete strength, then this is our own fault. Fine, because everything is its own limit. We are human body, we are also having our own limit. We can carry only few amount of load, not more than that. So we can't say that you are weak people, you are weak. Okay, so all materials having its own Limitations. So in rice husk ash, we can see that 10% replacement is we can do in a rice husk ash, and these are lots of applications of rice husk ash. This is like in a blended cement, in a green concrete, in high performance concrete, in refractory, in a roofing shingles, ceramic blades, insulators, waterproofing, oil spill absorbent, right? So these are the application of RHA. And here you can see the simple that rice green, its cover, after that it's burnt rice husk, and the after the grinding of that ash. Okay, so in a C, you in a A B C, the C portion similar look like a cement. And as I told, I will share all the chemical and physical properties. So here you can see that this is the compositions. Whatever we are observing in cement, such type of compositions are there. And here from the table, you can exactly get the idea of concrete which we made from RHA. So here different strengths are given: 20 megapascal, 25 megapascal, 30 megapascal, 40 megapascal. And here is the rice husk ash percentage replacement, water cement ratio, slump, then compaction factor. Okay, so from that result we can say that at which percent, right? So whenever slump is good. So definitely that percentage is also good. But this is the data from researchers' data. Okay, but if we summarize from researchers' data, then 10% replacement is good for everything, right? So here you can see the final setting, initial setting, right? So everything you can see from the figure, that setting time, water binder ratio, rice husk ash percentage replacement, okay, and all this data I'm discussing based on another researcher's experience. Okay, this is not my own experience, but yes, whenever we are reading any book, whenever we are reading any literature, so based on that we can discuss if we will use such type of things in a such type of manner, so such type of effect will be there. So my summary from rice husk ash will be 10% variation is a good, right? So properties of hardened concrete containing rice husk ash. This is achieved a higher strength relative to control concrete. Okay. In general, strength will be increased till 15% compared to control concrete, and this is the good sign, right? This is the drying shrinkage proportion as per the days. This is here control concrete. 10% replacement of rice husk ash and 10% of silica fume is given. Okay, but for that we will discuss in another slide. So whatever we discussed, same thing detailedly shown in a PPT. So I will not read each and every line. If any any audience want this PPT, then they can contact organizer. I will provide PPT, right? Then here you can see that control concrete 7% replacement, 10% replacement, 15% replacement, and there is a some durability also. Means they have tested their concrete cube after Na2SO4 curing, after MgSO4 curing, and they found good result compared to control concrete. Means 100% cement was there, and they are doing that different replacement and getting good results in a strength also, in a durability also. So rice husk ash is a good material. We can say it's a good smart construction material we can use in a concrete manufacturing. Then nanosilica, silica fume. So this is a byproduct of melting of silicon and ferrosilicon industry. This is a very effective in the design and development of high strength, high performance concrete. This is now a trade. Okay. But nanosilica is a one type of nanomaterial. So when we are dealing with that work, so we have to consider so many safety measures by using that. Otherwise, it will, what we can say, it will trouble the health and create lots of health issues. So here again, physical properties are given, right? Silica fume is there and nanosilica is there. So all the properties are given. So due to very fine particle, the surface area of given mass of silica film is very large. Silica film powder is commercially available in a white and gray color. Silica film consists of like very particles composed of pure silica and holds high content of silicon oxide dioxide. This non-crystalline silica is the main cause of pozzolanic reactivity of silica fluid. There are some trace oxide of iron, magnesium, and alkalis are also present in a very low percentage depending on the parent metal from where we collected that silica fluid, right? There are little bit strength and durability issues, but again here my statement, my comment is there. We can't blame that material. Why? Because lack of awareness, lack of knowledge, or we can say less number of standard specifications are there. No any good test series performed. So there are lots of reasons. So because of that reasons, there is a strength and durability issues. Okay, if one person or one team will consistently work on that particular parameter by altering different variation, by changing different parameters, then only they can give the confident result, right? Mr. X from Sri Lanka, Mr. X from India, Mr. X from another country, they are doing the work at different places, and based on that places, they are giving us the results. But if you are staying in India and you are having a good team from all the state, from all the district, so one good team will be there. They will work from that one topic, right, in a very consistently manner, and they will compare the result. That what is the result in Gujarat, what is the result in Maharashtra, what is the result in other state. Okay, so by comparing that, you can give the perfect judgment. Okay, so again I will tell that we can't blame material directly. It is having a good property, so definitely it's a smart material. And to make it a exactly smart material, our entire civil fraternity have to think think beyond that, that we have to do teamwork, right? But whatever university, whatever college, whatever place, we have to do good teamwork for good results, right? So this is the compressive strength of silica fume. You can see the percentage of silica fume and compressive strength. So here M50 grade of concrete is there. So there is a 7.5% silica fume replacement, sounds good. In M40 grade concrete, results is there. In M35 grade of concrete, 15% replacement is desirable. In M20 grade of concrete, 7.5 replacement is desirable when we are using silica fume in place of cement. Okay, and here we can see the development of compressive strength of high performance self compacting concrete with a different proportion of cement, silica fume, and nano silica, right? So here you can see that when we are using nano silica 2%, and that what we can say, another material as a 10%. So we are getting a good compressive strength of concrete after various days. So definitely I told there is a health and safety issues. This is the limitation, and because of that we are not using that much silica fume. When we are talking about metakaolin, so this is also a kaolin mine and can be found in different countries, including the Indian subcontinent like Southeast Asia, China, South America, North America, Australia. It is composed chiefly of the mineral kaolinite, which occurs in the deposit of China clay rock, a mixture of 15% China clay and 10% mica, and the remainder is a quartz. This is one of material. Metakaolin differ from the other supplementary cementitious material in that it is not a waste product resulting from industrial activities, nor it is completely natural. Okay. So we can say there is a purity of kaolin clay varies from 20% to more than 80%. And the main characteristic of metakaolin is the pozzolanic activity, which is the ability of metakaolin to react in the presence of water with calcium hydroxide to form hydrated silicate gel hydrated product possessing cementitious properties, and that is very important, right? So we can say that high reactivity of metakaolin that will affect the cement hydration. Okay, heat of hydration may be increased, setting time will become in picture. If temperature rise becomes critical in massive concrete elements, so it may lead to thermal stress also. So we have to also control the temperature of concrete. However, this property is desirable in cold weather concreting. Okay, so again I am telling that some concrete are good in a cold places, some concrete are good in a very hot weather. Okay, some are used in a marine structure. So we can say that every concrete having its own characteristic as per its application. Okay, that's why we considered it's a smart material. Why? Because in the cold countries where temperatures are zero in a minus degree, so at that basis we can use that concrete. So this is the advantageous thing, and that's why we are considering as a smart material. Okay. So I think time I am having, I have to complete in my given time limit. So now from all the smart materials, I am sorry, not all the, we discussed a few only. So from that few discussed smart material in concrete manufacturing, what is the conclusion? So global tendencies for sustainable development had their effect on the construction industry as well. Regardless of sustainability, fly ash has been used in concrete for decades because of its positive effect on some durability aspect and lower price. On its way from power plant landfill to concrete, fly ash overcome many obstacles, but there is still a long way until safe daily use in the construction industry is possible. GGBFS mostly improve durability properties of kind of concrete and mortar. Many properties of concrete or mortar such as permeability, creep, shrinkage, resistance to freeze thaw, sulfate resistance, alkali silica reactivity, abrasion resistance, high temperature resistance, resistance to chloride penetration and chloride binding capacity were examined. GGBFS it decreases permeability of concrete and improve resistance to sulfate and seawater attack. There seems to be lack of information about the reaction mechanism of nanosilica. A detailed study is required to investigate the nanochemistry to assess, interpret, and visualize the reaction mechanism in that. Development of new family of nano superplasticizer may be very useful for proper dispersion of nanoparticles which will result in extracting maximum benefit from using nanosilica. Using pozzolanic material in cementitious system can enhance the durability of material produced. Okay, so these all are the conclusion, but what I will summarize today, we are developing, okay, we are improving ourselves, we have to improve our technology. So as a civil engineering fraternity, what is our role whenever we are talking about any advancement, any development, then we have to focus that advancement and that development should increase our economy, should also protect our environment, and to protect our environment as the engineering and as the responsible citizen of country, we have to focus on that such type of materials which we can use in a place of cement or in a place of natural resources to save our environment and to reduce CO2 emission in environment. So this is my summary. I hope you enjoyed the session. If you need that PPT, please contact organizer. You can take my contact from them if you have any query, if you have any doubt, if you want to do any collaborative work in any specific area, then you can contact me. So here I am ending my presentation and telling thanks to each and everyone who listened me very peacefully. Thank you so much. Yes, Jason.
Yeah, wow, what an informative session it was, madam. I am sure students are sent us about this new insight you have shown regarding supplementary cementitious material, and definitely they will use in their research to reduce the carbon footprint and to save the mother earth. And we can say the cement manufacturer to produce the green cement using this sustainably cementitious material. So it is very fruitful lecture. Now I will request Professor Jayashiv Thakkar to conclude the session with vote of thanks.
Yes, sir. So first of all, I would like to say thanks to Damayanti ma'am. What a fabulous informative session it was. I am sure that all students are fully recharged and get motivated through your lectures. I am Jayashiv Thakkar, Professor of Civil Engineering Department. On behalf of Civil Engineering Department and Parul University, I extend heartfelt thanks to Miss Damayanti ma'am. Thanks to delivering your lecture and such a motivational talk. Despite of your busy schedule, uh, is kind enough to accept our invitation. Ma'am, we would like to listen to you in future as well, and we would like to invite you physically to the university. Once again, thank you, ma'am.
Thank you so much, sir.
Thank you very much. Good day, madam.
Okay, have a good day to all. Please stay safe, take care. Corona is not over yet. Please take
Yes.
care of yourself. Please enhance your knowledge. Stay
Thank
safe,
you.
study well, take care. Thank you.
Thank you very
Thank
much.
you, ma'am. Sir, webinar is over.